Welcome to science class. Today we'll be learning about the features of Mercury, Venus, and Mars. These planets were known to the ancients because they're easily visible. Venus is the brightest object in the evening and morning sky apart from the sun and the moon. Mercury is harder to spot because of its proximity to the sun. Mars, being the one farther from the sun than Earth, is only visible after twilight, but its red color makes it stand out. Each of these planets is named for the Roman equivalent of the Greek gods, which we are more familiar with thanks to popular culture. Mercury, the swiftest moving planet, was the messenger god in Roman mythology, who is of course Hermes to the Greeks. Venus is the Roman goddess of beauty and love, who to the Greeks was Aphrodite. Mars was Rome's god of war. The Greeks worshipped Ares. Each of these planets is very similar in composition. Their surfaces are rocky, not icy. Their cores are made of metals. But being giant floating rocks in outer space is just about the only thing they have in common. Let's get started. Mercury is the innermost and smallest planet. At 4,878 kilometers, it's 38% the diameter of Earth and only 400 kilometers wider than the Moon. There are 3 moons in our solar system, in fact, that are larger than Mercury. But none of them are as massive because Mercury contains large amounts of metals and those moons do not. Mercury's surface also looks a lot like the moon's. There are smooth terrains, but many craters and highlands. Mercury doesn't have true mountains or valleys, but the terrain varies. The highest point on Mercury rises almost 3 kilometers above its base, and it's the rim of a giant impact crater. With no surface water, tectonic activity, or atmosphere, Mercury's surface preserves the way it was billions of years ago. The surface of Mercury only changes when an asteroid hits it. The surface of Mercury is likely 3.5 billion years old at the youngest. The surface of Mercury can teach us a lot about Earth. Mercury's heavily cratered surface supports the hypothesis about how solar systems and planets like Earth are formed, out of the collisions of trillions of rocky space objects. Unlike Earth, Mercury still bears its scars from long ago. When we look at these craters, it's hard to understand how large they are. These craters are hundreds of meters deep, and many of them are several hundred kilometers across. The surface of Mercury has massive faults, which we call scarps. These formed as these small planets solidified much more rapidly than the larger planets. As it went from molten to solid, its volume shrank. The surface of Mercury appears to have fractured as it reduced its overall volume. Mercury's core extends through more of the planet than any other planet, but it's not the most dense planet. Earth is. The surface gravity of Mercury is weak, only 3.7 meters per second squared. Planets have what we call a sidereal and a solar day. A sidereal day is how long it takes an object to rotate 360 degrees. What we call a day is a solar day, or how long it takes the sun to appear at the same part in the sky on 2 consecutive days. A solar day on Earth is almost exactly 24 hours, but a sidereal day on Earth is 4 minutes shorter than that. As Earth orbits the sun, it needs to rotate a little bit more in order for the sun to reach the same point in the sky, hence why the solar day is longer than the sidereal day. We will compare sidereal and solar days on each of the other 3 inner planets. Mercury's sidereal day is about 59 Earth days, but the solar days on Mercury are 176 days long. This is because Mercury is very close to the sun and rotates so slowly. Mercury rotates in the same direction it orbits, counterclockwise. This causes much of its rotation to be canceled out, you could say, by its orbit. Earth's moon takes this to the extreme. The moon rotates at exactly the same pace, you could call it, as its orbit. The moon does spin, it's just that the same side of it always faces Earth. We will learn more about this in future episode. The same kind of thing occurs on Mercury, just nowhere near as extreme. Mercury is only 58 million kilometers, or 0.4 astronomical units away from the sun. This makes the Mercurian year only 88 Earth days. Mercury's proximity to the sun makes it hot. Very hot. It gets up to 430 degrees Celsius on Mercury, more than hot enough to melt lead. But Mercury can also get down to negative 180 degrees Celsius, colder than it gets on Mars, which is almost 4 times farther from the sun than Mercury. So how is that possible? The dark side of Mercury faces away from the sun for so long, and Mercury has no atmosphere. So being on the dark side of Mercury is really no different than floating in empty space. And because Mercury has no atmosphere, there's no thermal insulation. But Mercury's dark side is not where you find the coldest temperatures. Mercury's tilt is only about 2 degrees, so the poles never get direct sunlight. Mercury's surface is also heavily cratered. There are craters on Mercury's poles that are deep enough that sunlight never touches the bottom. This, combined with no atmosphere and no way to retain any heat, leads to the extremely cold temperatures. Mercury has the greatest differences in highest and lowest temperatures than any other planet by a really long ways. Venus is the second planet from the Sun and is close to Earth in size, only 640 kilometers smaller in diameter. It's also very similar to Earth in composition, Earth being only around 5% more dense, and Venus being about 82% the mass of Earth. The surface gravity is 8.87 meters per second squared compared to 9.8 on Earth. But there is where almost all of the similarities end. Venus's surface cannot be viewed directly. Its atmosphere is too dense. The Venusian atmosphere is 93 times the mass of Earth's. The air pressure is the equivalent of being under 900 meters of water. The yellow shroud of cloud coverage over Venus is sulfuric acid. It rains sulfuric acid on Venus. But the majority of Venus's atmosphere is carbon dioxide. On Earth, carbon dioxide makes up 0.04% of our atmosphere. The insane amount of carbon dioxide in Venus's atmosphere, which remember is almost 100 times more dense than ours, makes the temperatures on Venus incredible, 462 degrees Celsius. Venus, in fact, is the hottest planet, not Mercury, and the temperatures on Venus remain this high almost all the time. The Venusian surface is interesting in a number of ways. You could have guessed, but there's no water on Venus, not even water vapor in the atmosphere. Venus's surface is covered with mountains and volcanoes. Big mountains too, up to 10 kilometers above the average diameter of the planet. Around 80% of the Venusian surface is covered with lava flows. The surface is not nearly as dense with craters as Mercury, which tells us that the surface has been covered by new material. We just don't know how long ago. While Venus is tectonically active, the planet doesn't have plate tectonics, and the reasons why help us understand plate tectonics on Earth. The solid crust beneath our feet has a lot of water locked within it. That water aids in driving plates into one another and helps soften and pull plates apart. Water-laden rock has a lower melting temperature, and it lubricates the plates as they collide. The rocks on Venus are baked from the high temperatures. This has locked the lithosphere in place. It is simply too hard and too brittle to be able to shift like Earth's can. Venus is 108 million kilometers from the Sun, 0.72 astronomical units. The Venusian year is a bit over 224 Earth days, but the days on Venus are very strange. A sidereal day on Venus is 243 Earth days. Yes, longer than it takes to orbit the Sun. With the Venusian day and year being so close to the same length, this would make the solar days on Venus long, decades long. But they aren't because Venus rotates backwards. The solar day on Venus ends up being about 117 Earth days. We don't know why Venus rotates so slowly and clockwise rather than counterclockwise. Perhaps early on in its formation, Venus got hit by another planetesimal in such a way that it reversed its direction. Or perhaps not. Because of Venus's slow rotation, it generates no magnetic field, the only planet that doesn't have one. Venus is also the most spherical planet because of how slowly it rotates. Earth is about 43 kilometers wider in diameter across its equator than it is from the North to South Pole. Rotating objects bulge in their center. But because of Venus's incredibly slow rotation, it has the smallest bulge. I can't believe I just said that. Like Mercury, Venus has no moons. On to Mars. We know more about Mars than any other planet by a long ways. Various countries have sent around 80 missions to Mars, but only about half are successful. 11 of the first 14 missions to Mars by the United States and Soviet Union were failures. Politicians, bureaucrats, businessmen, and other people would look at this record and probably declare, nope, that's it, no more trips to Mars. While it's true that sometimes we spend tens of millions of dollars on a project and get nothing in return, although failure is often the fastest way to learn something, the price for doing nothing at all is that we also get nothing in return. It isn't expensive to go to Mars. All it costs is money. It's expensive not to go to Mars. If you've ever used something cordless or lightweight, if you've ever been on a computer, used batteries, wore running shoes, slept on memory foam, driven on grooved pavement on the interstate, filtered your water, wore scratch-resistant glasses, flown on an airplane that didn't crash because of ice buildup, taken a 12-megapixel selfie with a camera the size of a pea, used a computer mouse, had LASIK eye surgery, benefited from an artificial limb, benefited from cochlear implants, had your temperature taken with an infrared thermometer, used LEDs, worn invisible braces, had your life saved, or at least your conscience eased by flame retardant material, consumed or used baby formula, or used solar cells, you can thank NASA for its invention or for its improvement. Okay, rant over. Mars is the fourth planet from the Sun, orbiting at 228 million kilometers from the Sun, 1.524 astronomical units. Mars is probably a lot smaller than you think. It's only 6,779 kilometers across, 53% the diameter of Earth. Mars also has a meager density, less than 4 grams per centimeter cubed. The other terrestrial planets have a specific gravity well over 5. Mars is only 10.7% the mass of Earth. The surface gravity is 3.711 meters per second squared, which is very slightly greater than Mercury's. Mars is about twice the mass of Mercury. However, your weight on each planet would be almost identical. Here's the formula for calculating the force of gravity on a planet. Let's plug in the universal gravitational constant, Mercury's mass, my mass, and divide this by the radius of Mercury squared. That's how much I weigh. Here's how that all works out for Mars. That bottom value is why you weigh almost the same. Yes, Mars is almost twice the mass of Mercury, but its radius is 950 kilometers wider, and we are squaring that number. We think that gravity pulls us to the surface of a planet, but it doesn't. It pulls you towards the planet's core. You just can't pass through solid ground. So because the force of gravity weakens with distance from the center, you weigh less on a high mountain than you do in a low valley. Your mass does not change, but the force of attraction between you and the world you are on does. That's what weight is. We are getting heavily sidetracked here, but Mars is a great place to apply a lot of extra learning. A sidereal day on Mars is 24 hours, 37 minutes, and 22 seconds. A solar day on Mars is only 2 minutes and 13 seconds longer. Living on Mars would feel normal in that way to us. The days are just a little bit longer than Earth days. The years on Mars are 687 Earth days long, 322 days longer than ours. Mars has an atmosphere, but it's less than 1% the density of Earth's. Hurricane speed winds occur on Mars, but you would barely feel them. Temperatures on Mars range from 20 degrees Celsius down to negative 153 at the poles. This is colder than the temperature of dry ice, frozen carbon dioxide. Mars has a similar axial tilt to Earth, 25 degrees. During the winters at each pole, significant portions of Mars's atmosphere become frozen dry ice, and the polar ice caps of the planet grow. During the Martian spring, the ice caps sublimate, convert from a solid directly to a gas, and the polar ice caps shrink. Despite the fact that it is a small world, Mars used to be just as dynamic as the Earth. Mars also boasts a large number of the most impressive features in the whole solar system. The most striking is the gigantic Valles Marineris. This is a huge rift, 4,000 kilometers wide and 7 kilometers deep. It's the size of the United States. This rift tore open as the Tharsis Bulge was produced on Mars. The Tharsis Bulge is this gigantic plateau that juts out of the planet. The bulge probably formed from some sort of extreme magma hotspot rising to this one area of the planet. On this plateau sit 3 of the largest volcanoes in the solar system, but just off the plateau is Olympus Mons, which is a lot bigger. This volcano is the size of Arizona. The Big Island of Hawaii, Earth's largest volcano, is about 23 times smaller in surface area than Olympus Mons. Olympus Mons is 25 kilometers tall. Everest is less than 9 kilometers tall. You can just barely make out Hawaii on a globe, whereas Olympus Mons is extremely conspicuous on the surface of Mars. How such huge features can be produced on a small world is still a mystery to us. These features are all extinct. Valles Marineris is no longer growing, and all of Mars's volcanoes are extinct. Mars is not tectonically active. It's essentially a dead planet. No significant geological, biological, hydrological, or atmospheric processes happen on Mars. But when we look at the surface of Mars, we see evidence of a rich and dynamic past. First of all, the Tharsis bulge shows us that Mars was active for a significant portion of time after Mars's initial formation, because we find barely any impact craters on its surface. Compare that to Mars's southern hemisphere, which is covered in craters. Meanwhile, Mars's northern hemisphere also has very few craters. The Martian northern hemisphere is also extremely smooth. It used to be the Martian Ocean. Mars doesn't have any mountain ranges or systematic rifts like Earth does, so we don't know how most of the northern hemisphere got to be so smooth and low-lying. One theory is that the entire basin is an impact crater. It would be the largest impact crater in the solar system by far if it were, but this is hard to confirm. We can confirm two other impacts on Mars's surface. The first one has been named Utopia, which is a terrible name for a place where an asteroid destroyed part of the planet. Utopia is not a complete crater. Its outer edges have been disturbed by other impacts and various geological processes, but we can measure its basin, and it's some 3,300 kilometers across. That's 80% the diameter of the United States. Imagine an impact that would do that. Turn 80% of the United States into a bowl-shaped depression. You're talking about an impact that would destroy maybe even all unicellular life on Earth. It would likely make the entire planet so hot that all of the world's oceans would evaporate. The Hellas impact crater is a complete crater, and the largest visible one in the entire solar system. At 2,300 kilometers across, it's half the width of the United States. The Hellas impact crater is antipodal to the Tharsis bulge, meaning it's on the exact opposite side of the planet. It's possible that the impact that created Hellas drove molten material towards the opposite side of Mars, creating the Tharsis bulge. So that's the largest rift, several of the largest volcanoes, and the largest impact craters in the entire solar system on the second smallest planet. Good job, Mars. So I kind of nonchalantly brought up that Mars had an ocean and then just moved right along. We're going to talk about that some more here. We don't know how long Mars had water, but it could have been as many as 1 billion years. The smoothing of the basin in its northern hemisphere is clear evidence of sediments depositing over very long periods of time. Dry riverbeds can be found all over Mars. The easiest ones to spot come out of the enormous Valles Marineris. If we zoom in close, you can clearly see that these winding channels were created by water erosion. You can even see how impact craters have been eroded by the water. In other regions, we can see depositional features from flowing water, including deltas. A crater with one of these deltas is the site of the Perseverance rover, which just landed on Mars a few days ago. Mars also has sedimentary rocks, and a lot of them. You can find shale, conglomerates, and sandstone, including cross-bedded layers, which are the telltale sign of flowing water depositing layers. In order to produce sedimentary rocks, you need a dynamic planet with a range cycle, and a lot of time to allow for erosion and deposition. So why does Mars not have an ocean anymore? It's because Mars lost its atmosphere as well. An atmosphere is crucial for being able to have liquid water on the surface of a planet. Although we don't feel it, the atmosphere pushes down on us with tremendous force. Without atmospheric pressure, the surface is exposed to the near vacuum of outer space. Liquids will not remain liquid in this near zero pressure environment. They convert directly to gas. I can show you. This syringe is filled with water that's about 46 degrees Celsius, well below the boiling point. But if I pull the plunger back, greatly decreasing the pressure within the tube, the water boils. But now we have to know, why does Mars not have an atmosphere? That is because Mars lost most of its magnetic field as well. Mars is way less dense than Earth. So Mars likely has fewer radioactive isotopes in its mantle and core, which keep the planet hot inside. Mars is also just too small to maintain the pressure to keep its interior hot. Mars's interior dynamo basically turned off. While the Martian day is similar to Earth's, Mars still spins much slower because it's smaller, and Mars no longer has a liquid outer core. The combination of those things allowed the solar wind to slowly blast away the Martian atmosphere as the magnetic field gradually dissipated. Mars still has a lot of frozen water ice on its surface, and perhaps huge amounts just under the surface. The Korolev crater has an estimated 2,200 cubic kilometers of ice alone. Mars has 2 moons, which are just captured asteroids. They're really small. They were discovered way back in 1877. In ancient Greek mythology, Ares had 2 sons named Phobos and Deimos, meaning fear and dread. That story is thousands of years old, And we just so happened to find 2 moons orbiting the planet coincidentally named after the god who has those 2 suns. So the moons were fittingly named Phobos and Deimos. Next time, we are going to explore the Jovian planets Jupiter, Saturn, Uranus, and Neptune. Thanks for watching.